Hello, everybody. This is Mr. Frank, and I am going to make a little video here for the Geometry Final Exam Review Part 2. Just going to go over a couple of the big questions that you are going to face. There is another video on perpendicular bisectors, which I'm going to do right here. So I'd recommend that you check out that one. It goes a little bit more into detail, but I'm just going to do a quick version right here. Say with question number 1. So I'm going to block out very quickly because it requires a lot of room. You're only going to have to do one of these. I put a couple of these here for you to practice. All right, here we go. All right, step number 1 is understanding what we're even doing here. So here it says, write an equation of the locus of points equidistant from 3, 5, and 7, 3. Your question will say, write the perpendicular bisector. That actually means the same thing as locus of points, but you don't need to worry about that. So here we go. Step 1, I'm going to give you a graph paper, so you might as well put the points on there. So 3, 1, 2, 3, 4, 5. It's right there. And 7, 4, 5, 6, 7, 1, 2, 3 is right there. Now, the goal here is to kind of imagine the line that's connecting these two and find the equation of the line that's going to go in exactly the opposite direction, the perpendicular direction, and exactly in the middle. So that's our goal. So here we go. Step 1, you got to find the midpoint. Why? Because the midpoint is the exact point where the line that we're going to want to write the equation for is going to go through. So the formula for midpoint is x plus x of those 2 points divided by 2 and y plus y divided by 2. Remembering that this is the x, this is y, and this is the x, and this is the y. So I'm going to start right over here. So I'm going to take the 2 x's, which is 3 and 7, add them and divide by 2. And I'm going to take the 2 y's, which is the 5 and the 3. And I'm going to add them and divide by 2. I'm going to do the next part in my head. 3 plus 7 is 10 divided by 2 is 5. And 5 plus 3 is 8. 8 divided by 2 is 4. Now, this point right here is very important. I'm going to go find it here and go 1, 2, 3, 4, 5. 1, 2, 3. Sorry, 1, 2, 3, 4, 5. 1, 2, 3, 4. It's right there. And as you can see, it's exactly in the middle of those 2 points, right? So that's why this graph is helpful, because it makes you more confident that you're on the right path here. All right. Now, the next part is we have to figure out what the slope is going to be of this line, but we can't know the slope of the line that we want to write until we know the slope of the line that would be connecting these two. I'm going to put a little dotted line right here. It's not the line that I want, but, you know, I'm like, you know, what's the slope of this line right here? Because if I know the slope of that, I could just take the negative reciprocal and know the slope of the perpendicular line. So here we go. Step 2, slope. Of course, you need to know the formula. This formula is y2 minus y1 over x2 minus x1. We've been using this forever. All right, so here we go. I'm going to use the same 2 points here and plug them in here. They're all positive, so I don't really need parentheses. So I'm just going to go call these my 2's over here, this point right here, the 7, 3. So I'm going to say 3 minus 5 over 7 minus 3. And that's going to equal 3 minus 5, which is negative 2, over 7 minus 3, which is 4. I'm going to put that into my calculator, negative 2 divided by 4, and ask it to simplify it for me. And that's going to simplify to negative 1/2. Awesome. And that should make sense when we look here, because negative 1/2 means down 1 across 2. down 1 across 2. Yep, perfect. However, we don't want the equation of that line. What we want is the equation of a line that's going to be perpendicular to that one, which takes us to step 3. You have to understand the concept of negative reciprocal, right? Negative reciprocal slope, right? Sometimes I like to write perpendicular, the upside down T, slope, right, is really equal to negative 1 over m. Well, that's kind of technical here. Sorry for that, but that's what it looks like if you're going to be super technical. But all this really means negative 1 over m means whatever your m is, which is negative 1/2, this negative here means change the sign. Okay, well, this slope is negative, so my slope has to be positive. And the 1 over m means just flip it upside down. All right, so I got 1 over 2 over here, so I'm going to put 2 over 1. But I don't really have to put anything ever over 1 because 2 divided by 1 is just 2. So I could just stop right there. My negative reciprocal slope is positive 2. Perfect. Now that should also make sense when I come back here, because if I do a positive 2 slope from this point, I go up 2, across 1, up 2, across 1, down 2 to the, oh yeah, that line right here certainly does look perpendicular to the first 2 points and going through the middle. That's what a perpendicular bisector is. All right, so now we just have to be able to write the equation, which is our final step. Well, the easiest way to do it when you're given 1 point, which I have right here, and you're given the slope, which I have right here, is use something called point slope form, which is y minus y1 is equal to m times your x minus your x1. And it's really just a substitution at this point. So I'm going to rewrite this y. And then negative y really means the opposite of your y. My y is up here, it's 4, so it's going to be minus 4, is equal to my m, which is 2, parentheses x, and the minus x1 means the opposite of my x. My x is up here, it's positive 5, so minus 5. That's all I got to do. And there you have it. So just in summary, this is a big question on your final exam, writing the perpendicular bisector. It's a 4-part question. Finding the midpoint, because you're going to use that point. Finding the slope, because you're going to need the negative reciprocal of that. And then just creating the equation. Also, if you can make that graph, it's going to be a bonus 2 points, turning this into a 6-point question on your final exam. So all of you who are watching this video will know that this is a 6-point question and have a little advantage over everybody else. All right, let's move on to some other big questions. All right, there's going to be some constructions, but I'm going to go over those in class for your last class. But let's jump to some trigonometry questions here. All right, so SOHCAHTOA. There's going to be a bunch of SOHCAHTOA, trigonometry. So I'm just going to pick one of these to do. I'm going to pick number 8. I don't know which one is on your exam or what it's going to look like, but you're definitely going to have some trig. All right, so let me put this on its own page right here. And yeah, this question might be a little bit harder because there's no picture, right? So you're going to have to read these well and do your best to get a picture of what's happening. All right, so let's read it. A 10-foot ladder is placed against the side of a building. The base of the ladder must be placed at an angle of 72 degrees with the level ground for secure footing. Find to the nearest inch how far the base of the ladder should be from the side of the building and how far up the side of the building the ladder will reach. This is a 2-part question, right? This is a big one. So we picked a good one here. All right. So as soon as I kind of get the idea that it's a trigonometry question, you know, I kind of want to create a triangle here. All right, I'm going to a right triangle. So I'm just going to draw a right triangle. And oops. And once I have that triangle, you know, it's kind of obvious where the right angle is. So you might want to put in your little 90-degree angle. Now there are some clues here as to where to put these numbers here, right? There's two numbers that need to go into this problem. A 10-foot ladder, right? A good hint about ladders is that ladders are always leaning, right? They're always diagonal, right? So if they tell you that you have a ladder and they tell you how long it is, that's almost always going to be the hypotenuse, which is over here, 10 feet. And the clue for the angle, which has to be one of the acute angles, it says it's made with the ground. The angle, this is the ground, obviously. So the angle, there's only one angle, there's an acute angle here and here. This we already know is 90. So I'm going to put my 72 degrees right here because that's the angle made with the ground right there. All right. Now, this was a two-part question. So let's do the first one first. Find to the nearest inch. That means they didn't say tenth or hundredth, so I'm going to round it up to the nearest whole number. How far the base of the ladder should be. Base is the clue. Whenever they say ground or base, it's going to be down here, right? How far should the base of the ladder be from the building? Or, you know, like this is the building over here, and this is the base. So I'm going to put my X right there. And now we start what we learned about SOHCAHTOA. All right. So remember, I'm going to build my bow. I'm going to shoot my arrow, and it shoots across, and it hits this side right here. So that this is going to be my opposite. We always know that the diagonal is our hypotenuse. And then the third leg is always going to be my adjacent. Now, we always need to eliminate one of these sides. I certainly need my X. That's what I'm looking for. So I need my A. And I need this number 10 to help me out. So I need my H. So the side that is irrelevant in this particular part of the problem is my O, leaving me with A and H. SOHCAHTOA helps us figure out which function we're going to use by process of elimination. We only have an A and an H here. Only one of these has an A and an H, and it's Ka. And the C stands for cosine. So I write down cos. Always of the angle that we were using, and that is 72 degrees. And the A and the H also helps us know where to put the X and the 10, right? The A comes first. That means it goes on top. That's my X. And the H goes on the bottom, and that's 10. Oh, look at this. This is a problem that has X on top. I like those because all I got to do is put this over 1 and cross multiply to get my X isolated. X times 1 is X. And 10 times cosine of 72 is exactly that. 10 cos 72. And I'm going to go to my, in this case, I'm on my computer here. So I'm going to go to the Desmos calculator. And I'm going to put 10 cos 72. Let's do that. 10 cos 72. Now you see I have a negative number. That's because sometimes when you're in Desmos, you're in radians instead of degrees. So we put it back to degrees. And I get 3. If this was to the nearest tenth, it would be 3.1, but it's to the nearest whole number. So we're just going to write 3 feet. 3 feet. And since I have X over here representing the side that I can just leave it like that because I know where X is. All right. We're halfway done. All right. So we did that. And how far up the side of the building? So I already used X here. So I'm going to use Y to represent how high, right? That's the key there. So I'm going to say this is my Y. And now in this particular problem, I need my O because that's the Y. I need my O and I need my H because that's the 10. So an O and an H is going to be a sine problem. So here I'm going to do the sine of 72 is my O over the H. So it's going to be my Y over 10. Again, I end up with variable on top, my y on top. So I'm going to do the same thing. Cross multiply. I'm going to get y is equal to 10 sine 72. Y is equal to, I'm going to go to my Desmos calculator. I'm just going to tap up here and change that to a sine. And I get 9.5, which will round off to 10. And there you have it. Please, there could be some SOHCAHTOAs and trigonometry problems on the exam that have x on the bottom or x as the angle. So please consult the trigonometry video on Mr. Frank's YouTube channel. All right, let's go back here and do one more problem. All right, we got some big problems here. Okay, these are solid geometry application problems. So let's start with number 12. Maybe we'll go through both of these really quick. All right, it says Jed bought a generator that will run for 2 hours on a liter of gas. The gas tank on the generator is a rectangular prison with dimensions 20 centimeters by 15 centimeters by 10 centimeters. If Jed fills the tank with gas, how long will the generator run? Good question. There are a couple things you need to know about cubic centimeters and the fact that 1 cubic centimeter is equal to 1 milliliter. And then, of course, there's 1,000 milliliters in 1 liter. Those are very important. If you don't know that, this problem becomes pretty difficult. All right, here we go. Step 1, let's find the volume of this rectangular prism. So the formula is quite simply length times width times height. So in this case, it's going to be, when you're doing a rectangular prism, it doesn't matter the order. So I'm going to say my length is 20. I'm going to say my width is 15 and my height is 10. And we get a volume of 3,000 cubic centimeters, which is the same thing as 3,000 milliliters because it's a 1-to-1 conversion, which means in order to convert this into liters, all we got to do is divide by 1,000, which means our volume is actually converted into liters is nothing more than 3 liters. Well, it told us up here that you get 2 hours for every 1 liter. Well, if I get 2 hours for 1, I get 4 for 2, and I get 6 for 3, right? We just got to multiply that by 2. And the answer to this question is you get 6 hours. All right, and then the last question I'll do is right here. This is a classic question. I can see I have a rectangular prism that's going to be filled with water that's 10 inches by 15 inches by 20 inches. Hey, look at that. It's the same dimensions as the tank on the left. That's going to be an easy calculation. But then we have a cylindrical cup that has a radius of 2 inches and a height of 5. What's the maximum number of full cups of water that can be placed in the container without overflowing? That's the key word there. All right. So very quickly, sure, we got to calculate the volume, but we just did here. So we already know that if we just look over here, I'm just going to do it really quick, that we know that this is going to be 3,000 inches cubed because it's the same dimensions here, 20 times 10 times 15. But we also have to find the volume here of the cylinder, right? So we know how many go in there. So the volume of a cylinder is nothing more than the area of the circle, which is pi r squared, times the height of the cylinder. Well, if I put that in there, I got my radius. I'm gonna put the pi at the end here and keep it in terms of pi. So my radius is 2, so it's going to be 2 squared times 5, and I'm going to stick the pi at the end, which means the volume is going to be 2 times 2, which is 4 times 5, which is going to be 20 pi. All right, so I got 20 pi worth of this, and I want to know how many of these 20 pi's fit into the 3,000. Well, quite simply, that becomes division. But be very careful. Notice that I'm keeping this 20 pi because I don't like to round off early. However, if you ever divide a number by a product of a number down here, meaning that this 20 is kind of multiplying by pi and I'm leaving it like that, if you put this in the calculator straight up, you're going to get the wrong answer because it's going to go 3,000 divided by 20, then multiply by pi. But we want this to be one number down here. So I'm just going to put that in parentheses. All right, let's see what happens when we put that into our calculator. So let's go back to Desmos, and let's put 3,000 divided by, I'm going to use parentheses, 20, and I need to go to my calculator here to find my pi right there, and close my parentheses. And I could see it's 47.746, blah, 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 blah. So normally you might feel inclined to round that off to, 48 cups, Mr. Frank. However, if you think about it, it's exactly 47.746 that's going to put the water exactly at the top. So if you round up, which you are inclined to do, which is normal, which makes sense, you are going to spill water. So you do have to kind of add a little logic to this question. Well, it said full cups. Well, I can't put 48 full cups because that's going to spill. So you have to kind of round down. So the answer to this question is actually 47 full cups. And there you have it. So I hope this was useful. I hope you watched this. If you did, you're going to have some very, very good wink, wink, wink clues about your final exam big questions. Don't forget to like and subscribe. See y'all later, everybody.